Hi, good morning. This is Mr. Cornier. This is benchmark number 28, last benchmark in this unit of quadrilaterals. We're going to be talking about trapezoids and kites. All right, so we've already covered benchmark 25, 26. We talked about special properties of special parallelograms. The special parallelograms is rectangles, squares, and rhombuses. And now again today we're going to talk about trapezoids and kites. All right, some vocab is trapezoid, bases, legs of trapezoid, base angles, isosceles trapezoid, mid-segment of a trapezoid, and a kite. Okay. Here goes some different theorems for an isosceles trapezoid. All right, so one, if a trapezoid is an isosceles, now remember what an isosceles means. The sides are going to be exactly the same. So if the trapezoid is an isosceles, and you got one pair of parallel lines, then each of the base angles are going to be congruent. So F equals G, or F equals J, and G equals H. If you have any questions on this first theorem of isosceles trapezoids, let me know. A theorem for an isosceles trapezoid is that if the trapezoid has one pair of congruent bases, so here goes the congruent bases, then it's an isosceles trapezoid. So if we know that angle L equals angle M, we know it's going to be an isosceles trapezoid. And the last one we have here is a trapezoid is an isosceles if the diagonals are the same. So again, you could pause this, reflect on it a little bit. Let me know if you have any questions. Welcome back, Mr. Cornier. This is example 1, benchmark 28. We want to go ahead and we want to solve for a measure of MJK. All right, so the first thing I do is I just label all the information on my diagram. This is a basket. Okay, each side of the basket is shown by this isosceles trapezoid. So we know that this equals this. We also know that JML is 130. And we know that KN is 6.7 and MN is 3.6. We do not need that information at this point. They are going to ask us for MJK. So this is 130. We need to figure out what that is. So what I'm going to do is I'm going to use the properties of consecutive interior angles. Consecutive interior angles. I know based on these lines being parallel, okay, I know that 130 plus x is going to equal 180 degrees. All right, so we're going to easily solve for x. Subtract 130 on both sides, and angle MJK is going to equal 50 degrees. Let me know if you have any questions. I'll talk to you later. Bye. This is example number 1, benchmark 28. This is letter B. So we're going to go ahead and label the KN 6.7 feet. And M to N is 3.6 feet. We want to find out what the distance for JL. So I know based off the properties of an isosceles trapezoid that the diagonals have to be the same. If the diagonal of K to M, so we're just going to easily add this up, 6.7, let's add that to 3.6, we're going to get KM equaling to 10.3. If Km is 10.3, then we know that J to L has to be the same distance. All right, if you have any questions, please let me know. Thank you. All right, for our first guided practice for benchmark 28, you're going to be able to read this carefully, and you are going to try to find the measure of E, F, G. All right, good luck, and hope you do well on this guided practice question. Okay, this is your second question on this guided practice. Each side of the basket shown is an isosceles. Measure of FGH is 124, FI is 9.8, and EG is 14.1. You want to find out the distance for I to H. Recall some of the properties for an isosceles trapezoid, and you should have no problem with this question. I'll talk to you later. Bye. Example 2 on benchmark 28. This is isosceles trapezoids and coordinate geometry. Quadrilateral ABCD has vertices A, 5, 1, B, -3, -1, C, -2, 3, D, 2, 4. And we want to show that ABCD is a trapezoid. And we're going to determine whether it's an isosceles trapezoid. So I'm going to go on my GeoGebra. I'm going to plot those points. I'll get right back to you in a second. Example number 2, I went ahead and plotted the points A, B, C, and D. You can see that right over here on the left side. I'm going to go to my tools, and I'm going to use the polygon feature. I'm going to start at A. Start at A, make my way all the way around B, C, D, A. Let me erase that line. Okay. Let me center this for you guys. Okay. Now I want to go ahead to see if the lines are parallel, to see if it's a trapezoid, because those lines have to be parallel. So the first thing I'm going to do is I'm going to go to my measure distance. It says select the line, so let's touch the line. My slope here is 0.25, and I'm going to do the same thing here, 0.25. So I know the lines are parallel. That's a good sign. So now, is it an isosceles trapezoid? After I figure out the sides, I want to go ahead. The second thing I want to do is I want to find out the distance between CB and CD. So I'm going to go to my measure, go to my length. I'm just going to touch on this. 4.123. If this is 4.13, then I know that it is going to be an isosceles. Since it's not, it is a trapezoid, but it's not going to be an isosceles trapezoid because these figures are not the same. If you have any questions, let me know. I'll be glad to help you out. Bye. This particular example, again, since the legs are not congruent, ABCD is not an isosceles trapezoid. All right, this is, again, example number 2. This is on isosceles trapezoids and coordinate geometry. All right, you have your points here. Q, R, S, T, Q, -1, 0, R, 2, 2, S, 5, 0, T, -1, -5, or -1, -4. You want to determine if it's a trapezoid. All right, so make sure the lines are parallel, the base, the two bases. And number 2, if it is a trapezoid, it is an isosceles, so make sure the legs of that trapezoid are congruent. Try it out on GeoGebra. You could do it by hand. It's going to take a little bit extra time, but it's your option. All right. Do a pretty good job at this, and look forward to seeing your answer. All right. Talk to you later. Bye. This is the trapezoid mid-segment theorem. So I'm just going to read this out. The mid-segment of the trapezoid is parallel to the base. So here's my mid-segment right here, BE. So basically what it says is that your BE is going to be half the distance of AF plus CD. So a quick little example would be, let's say this is 6, and let's say this is 10. To find the distance for BE, all you're going to do is 6 plus the 10. You add those numbers up and divide it by 2. Mid-segment, midpoint, 16 divided by 2, and the distance for BE is going to be 8. All right, let me know if you have any questions. Bye. Example 3, mid-segment of a trapezoid. This is 20, this is 30, and we want to find out what x is. We know this is in the middle, so the first thing I'll do is I'll try to find out the distance here. It's 10. So I know that this is the larger side, so I'll just add 10 to this as well. So my x would be 40. Again, when you add up the two segments, 40 plus 20, you're going to get 60, and you want to divide that by 2, which will also give you 30 for your mid segment. Any questions? Let me know. Thanks. All right, for this example, this is for example number 3. WXYZ is an isosceles trapezoid, the median with the medium JK. XY is, you got to find XY, and JK is 18, WZ is 25. So we know this is the smaller side. So what I'll do is I'm going to take care of the differences here and then subtract it from your median. So it has to be less than 18. So good luck on this, and talk to you later. Bye.